Hello student, let's start operating system. Inter-process communication and synchronization topic. Inter-process communication is a method of communication which is used to make communication between the process through which process interact with each other for gaining access to shared data and resources. There in process are the two types. First one is independent and the second process is a cooperative process. Independent process is a process are those process is whose task is not dependent on any other process. A process that does not affect or is affected by other process while its execution, then the process is called as an independent process. Cooperative process. Cooperative process are those processes that depend on other processes. They work together to achieve common tasks in operating system. It's called as cooperative system. Cooperative process. Cooperative processing in the split of an application into task performance separate computers. Okay. Next, inter-process communication methods. There are the two methods of inter-process communications. First one, share memory, and second one is a message passing. In share memory, in the share memory method, a part of a memory is shared between the processes. A process can write the data that it wants to share the other process. Similarly, another process read the data that have been written by the other process. Let's understand with this diagram. Share memory method in process communication. P1 write the data. P1 and P2 share the memory. Here, P1 write the data, share memory, transfer to share memory, and share memory. P2 is read the data from share memory. Here, the communication between between the two processes with the help of share memory. Okay. Next one is the message passing. In this method, two processes communicate each other with the help of message passing. Here, see this diagram. P1 message passed to the kernel and kernel send the message to the P2 process. Here, the communicate with each other with the help of message passing method. Okay. Next topic of in this chapter, we let's start the synchronization. In this OS, synchronization is a very important topic. Process synchronization is a task of synchronizing the execution of process in such as a manner that no two processes have access the same shared data and resource. In multi-process system, when multiple processors are running simultaneously, then may attempt to gain the access of the same shared data and resources at a time. This can lead to the inconsistency of shared data. That is, the change of made by the one process may not be reflected then other process access to the same shared data. In order to avoid this type of inconsistency of data, the process should be synchronized with each other. How does process synchronization work? Let's examine the precise reason why to process synchronization in OS is necessary. For example, in this case, there could chance to the data read for process 1 will be the incorrect if the process 2 attempt to change to data present at the same memory allocation while the process 1 is attempting to read it. Okay. Uh, See this diagram. Process 1 read the share memory and process 2 write the memory share memory, and process 3 also read this. Okay. Essential section for program. There are four sections are essential for a program. First one, entry section. Second, critical section, exit section, and reminder function. These is the sections of programs. Entry sections, the section determine when the process beginning. A critical section, they are permitted only the one process to modify the shared data and ensure that this in case. Okay. Next, say exit section. Exit one process has been finished running. It exits sections handle to the entry of other process into the shared data. Okay. And fourth one in reminder sections. These remaining sections portion, the code that is not divided into the categories listed above to the found in reminder sections. Next topic is what is race condition. Race condition occur when more than one process try to the access and modify the same shared data or resources. Because many processes try to modify the shared data or resources, there in her uh, chance to the process getting to the wrong result or data. Therefore, these process are rest conditions says to the has correct data resources, and this called the rest condition. Next, what is critical section? Problem. What is critical section do is make sure that only one process at a time has to access shared data for or resources, and only that process can modify that data. Thus, when the many problems try to modify the shared data or resources, critical section allows to only signal process to single process to access the modify the shared data or resources. The functions are very important in critical sections. Wait and signal functions to handle the entry process in critical section. Wait function is used, and other hand the signal functions is used to remove finished process from critical section. Okay? Rule of critical sections are three needed rules for critical section solving the critical section problem. Okay, mutual exclusion, progress, and bounded waiting. In mutual exclusion, make sure one process running in critical section means one process is accessing shared data or resources, then no other process enter in the critical section at the same time. Okay, and next progress if one process is in the critical section and some other process are waiting to enter into the critical section, now which process will enter into the critical section is taken by this process. Third one is bounded waiting. When new process make to request the enter into the critical sections where should not be some waiting or bound This bounded weighting equal to the number of process that allows to the access critical sections before it. Concurrent and dependent process. Concurrent processing is the features that allows to the no inter interactive data independent process, data independent, such the report process simultaneously with the online operation. With the concurrent process, you can complete non-interactive tasks without the interface pairings with the interactive work you perform at your computer. Dependent process. A dependent variable whose value depends on another variables, whereas independent variables is a variable whose value never depend on the another variables. Introduction of critical sections or semaphores. Critical section is a code segment where shared variables can be assigned. Atomic actions required to the critical section, that is only one process can execute in this critical section at the same time. This is a critical sections. Do entry sections, critical section. Next section is exit and then reminder. Solution of critical section problem. There are three types of solutions of critical section problem: mutual exclusion, progress, bounded weighting. In mutual exclusion, implies that only one process can inside the critical section at the same time, at any time. If any other process required to the critical section, they must be wait until to the free. Progress means that if the process is not using to critical section, then should not be stopped any other process for accessing it. In other words, any process can enter the critical section. It is free. Bounded weighting. Bounded weighting means that each process must have limited waiting time. It should not be wait endlessly to access the critical section. Semaphore. The semaphore is a just a normal integer value. Semaphore cannot be negative value. Its least value for a semaphore is 0. The maximum value of a semaphore can be the anything. The semaphore usually two operations. Two operations have two capability of decide the values of a semaphores. There are the two operations, wait and signals. Wait semaphore operations. Wait operation is used to the deciding conditions for the process to enter the critical sections or wait for execution process. The different names of wait semaphores is sleep operations, down operation, decrease operation, P functions. Most important lies name for the wait operation is P functions. The wait operation works on the basis of semaphores or a mutex value. Okay, next signal semaphores operations. Signal semaphore operations is used to update the value of semaphores. Semaphore value updated when the new process are ready to enter in a critical section. Known as signal operation, also known as a wake operation, up operation, increase operations, and V operation is the most largest name in a signal operations. Type of semaphores is a binary, and second one is counting semaphores. Binary means 0 or 2 binary values present in semaphores, and counting semaphores is two sets of values semaphores counting semaphores accept to the two types of values are values greater than or equal to 1 or critical sections. Advantages of semaphores. Uh, Semaphores are mechanisms independent since there is the implementations and codes for written for the kernel mechanisms independent code area. They strictly enforce mutual exclusion and lets process enter into the curricle part one at a time. Disadvantages of semaphores is due to the employment of a semaphores, it is a possible for high priority process to each vital area before low priority process. The wet and signal actions must be carried out into the appropriate order